All right. So after learning about the theoretical basics of machine learning, and obviously that wasn't in depth details, but overall the idea of machine learning, how overall AI and machine learning works. After learning those things, now let's go ahead and do some hands-on. And obviously, we're not going to do it by ourselves. We're going to take help from Mr. ChatGPT. So let's go ahead and we are going to use exactly the same data, right? And from on this data, what do we want to predict? We want to predict the selling price of the car. For example, I want to know what is the value of my car, right? Depending upon different factors like year, right? Kilometer driven, fuel type, um, let's say mileage as well, maybe engine as well, seats. Yeah, that's about it. I'm going to ignore rest of the columns, right? Again, there is a mechanism in machine learning where you can pick and choose most relevant columns as well. But here I'm going to pick and choose the columns by myself. So which columns am I going to choose? I'm going to list them down over here. So I'm going to go with year, and then I'm going to go with just to avoid any typo as usual. I'm going to copy and paste. Fuel. So fuel is going to be one of them. Then we have mileage, and then what? Then we have engine, and finally we have the seats. Seat or seats? Seats. Yeah, cool. Engine CC is obviously over here, so it will be extracted from here. So yeah, we're good to go. And what do we want to predict? We want to predict selling price. So selling price is our target column, and all of these columns are the feature columns. Depending upon these features, we can predict the selling price of any particular car. So we want ChatGPT to write a model, to write the code for us that will train an AI or machine learning model, or technically it is called model, machine learning model for us, by using which later on, if we enter this particular information, which is not there in this data set, if we enter any particular information for these values, we will get some estimated selling price, right? So let me copy all these column names. Let's come over here and let's upload the file. Do we need to upload the file, or we can let's just say use the data, or let's say use the data file from previous query, sorry, QU, yeah, from previous query, and write Python code to train a machine learning model to predict the selling price, not price, it's price of the car using these features, right? And then also write the code that will ask user to enter values for these features, and then it should use the ML model to predict the selling underscore price. Yeah. I think let's go. So it says that to create the machine learning model for predicting selling price, using the given features, we will do these things. First of all, we'll pre-process the data. We'll handle the missing values, categorical values, where, for example, fuel values has non-numerical values. So it will deal that. It will extract the numerical values from mileage column, from engine column. You see how intelligent it is. It is automatically telling us that this is not a numerical column, so we have to just deal with it. And these columns have some numerical values, so we'll extract the numerical columns from here, right? And then it is saying we are going to use, let's say, use regression model, for example, linear regression or random forest. These are the names of different models available in machine learning, and other models are also available to predict selling price. And then we are saying, then it will create some prediction interface as well, right? So here it is importing tons of different libraries, and then it is gonna do what? Let's see, what is it gonna do? It has also explained the code as well, right? So I'm just gonna copy this code. I'm gonna go to our Jupyter environment, and I'll paste it over here, right? I have pandas already available with me. NumPy is also available. It is also using Scikit-Learn. So I also have Scikit-Learn available with me. So if you don't have it, follow the same rule. Exclamation mark pip install Scikit-Learn, right? And then it is saying job lib library to save and load the model. I don't need that, right? I don't have to save the model anywhere, so I'm gonna ignore this, right? I don't have to load the data as well, so I'm gonna ignore this as well. I already have data in DF. And then what else? Here it is saving the model, so I don't need it. I'm just gonna ignore this. And what else is going on? I think that's about it. So let's go ahead and let's predict the price. So here, by the way, let's start from the beginning. What is happening over here? First of all, importing tons of libraries. Then sum of data preprocessing, converting engine column, extracting numerical values from engine column, writing it into engine column, doing the same with mileage column, handling missing values in engine, mileage, and seats column as well. And by the way, what is happening over here? Engine column, missing values in the engine column are replaced by the mean. Missing values in mileage column replaced by, again, mean. And missing values in seats column, they are replaced by mod, not mean. Remember why? If you don't remember, go ahead and watch previous videos again. Because seats cannot be a floating point number. Seat always has to be a whole number. Then what are we doing? We are importing label encoder. So in fuel variable, where's the fuel? Fuel is either diesel or petrol. So diesel will probably be replaced with 0 and petrol will be replaced by 1, right? So label encoding is happening over here. Then we are mentioning that these are the features. So all the features are going to X variable. So we are storing features in one variable, and the label, the target variable, is storing in another variable, which is called Y. Usually that is you can say, practice. Features are always stored in X and labels are always stored in Y. Okay. Then here is train test split is happening. So train test split, what is this train test split? Yeah, train test split is coming from here. We are importing it from Scikit-Learn. So basically we are passing X, which are the features, to train test split. We are also passing Y, which are the labels over here. And we are saying that the size of testing data set is going to be 20%. 0.2 means 20%. So for overall data, 20% of data should go to the testing set and 80% of data should go to the training set. Then the random state equals to 42, which means that if I'll restart this code again and again, this train test split, since it is a random split, so this randomness should remain same. Okay. Now what is happening over here? It is basically this function will return 4 different data frames. First one is going to be X train. Remember, wherever there is X, it means features. So training features are going to be here and testing features are going to be here. Same goes out, training labels are going to be here and testing labels are going to be here. Now both training sets, feature and label training sets, we will use them during training. For example, here we are creating a model called random forest regressor that is being imported over here from Scikit-Learn. So random forest is being imported, and here we are saying that model.fit. Fit means we are going to train this model. So we are training it on what? On X train, features of training, and labels of training. So during training, we are exposing both things, the features and the target as well, right? Both of things are exposed over here. Then once training is done, then we are using testing set to evaluate the model. Well, if this model is working fine, the trained model that is trained over here, if it is working fine on unseen data or not. Now, this unseen data is that testing data that we talked about in the theoretical video, right? Where this data was invisible to the model. So we only passed the X test, which means the features, these features. We did not pass the selling price over there. So we asked the model to predict the selling price for these features. Those predictions are stored over here. And then by using mean absolute error, we are checking out if these Y predictions, which are coming over here, are equals to the Y test, which means the actual labels of the testing set, if they're equal or not, right? So this mean absolute error, it takes the mean of the absolute of overall error, and it will display the values over here. So until here, our model will be ready. Then what do we have to do? We have to take inputs from the user. By the way, we are creating a method over here. So we will call that method. So what is happening over here? It is loading the data. Since we have removed all the lines related to loading the data, so I can remove this as well. And yeah, I think we already have this model ready over here. So we can use that model over here as well, right? So first of all, we are taking inputs over here, input in year column, kilometer driven, fuel, mileage, engine, and so on and so forth, right? So moving on, what are we doing over here? First of all, we are encoding fuel, right? Obviously, we will enter fuel like petrol, diesel, or whatever. So we'll encode that. And then we'll create a data frame of all the input features. Rest of the features are already in integer. Only this fuel is not an integer. So we'll convert fuel to integer over here. And then we'll create a data frame of the whole input data, right? And then we'll say model.predict, we'll pass input data to it. So it will get us the prediction, and that prediction will be shown over here. So let's go running it. Let's see if we are able to run it without error. It is running. So yeah, the mean absolute error is this much, which is huge, right? Probably we are doing something wrong. Either we are picking wrong model to train with or wrong data set to, whatever it is, that's an in-depth discussion. We can again go to ChatGPT and we can ask, it is giving us a lot of error, how to reduce the error or something like that. So it is telling us that this much is the mean absolute error. Fine. So enter year of the car. So let's say my car is of model 2015. Then it says how many kilometers it is driven. Let's say it is driven 50,000 kilometers. 50, 1, 2, 3. Okay. Enter a fuel type. Let's say petrol is my fuel type. Okay. Enter the mileage in kilometer per kg or whatever, kilometer per liter. Let's say mileage is going to be, how is usually the mileage is available over here. So let's go with 20. Okay. I'll say 20 is going to be my mileage. Engine capacity, let's say my engine capacity is going to be 1999, right? Enter how many seats in my car. Let's say 5 seats. Entering, here we go. So estimated price is going to be this much of my car. Since the data belongs to the cars that are available, this data belongs to India. So it automatically guessed it. And you see the currency is also being shown in the Indian currency symbol. And if the data belongs to the US or Europe, it would show the relevant symbol. From where the symbol is coming, you see over here. Since we copied the data from ChatGPT, so ChatGPT intelligently incorporated this symbol over here, right? So yeah, that's about it. So for example, this is my car with these features, not these features, with model 2015, with kilometers driven 50,000. Petrol is the fuel type. 20 is the mileage, 20 kilometer per liter. 2,000, almost 2,000 is the engine capacity. 5 is the seating capacity. And this much is going to be the estimated price of my car with this much absolute error. So this is how we can create any machine learning model. Actually, this is not only a machine learning model. We have perhaps we have created a complete application that can tell us the price of a car. If you want to predict price of a house, you want to predict, let's say, if tomorrow it's going to be rain or not, you want to predict anything else, just write the relevant data over here. Just pass the relevant data to ChatGPT and it will get you the code as well. So if you don't want the code, you just want the predictions, you can say, hey, this is my code. This is my data file. and these are my values on which I want to test it, or I want the predictions. It will give you the prediction without code as well, along with explanation. If the model is not working fine, if the error is too much, we can again go back. We can say, hey, I'm getting too much error. Either change the model or suggest me what should I change inside the code or inside any hyperparameter or whatever that will help me getting better accuracy or getting lower error, right? So again, go back and forth towards ChatGPT and you will get your estimate, your desired results as well. So that is about machine learning. That is about data analysis. That is about overall the libraries of Python. We have um, only covered a few libraries in Python. In very first section, we learned that there are hundreds of thousands of libraries available in Python. So again, go ahead, go to ChatGPT, ask, write your use case over here. What do you want to do by using Python? And ask ChatGPT what is the most relevant library that you should use over there, right? These libraries like Pandas, NumPy, Scikit-Learn, Matplotlib, Seaborn, Plotly, these libraries are kind of benchmark libraries in data science domain. So if you're looking your career in data science, you should check out these libraries in depth. To move on,